Hi, in this problem, we are going to look at a counting problem, and the question goes like this. If the number of ordered triples A, B, C, such that the LCM of A and B is 1000, the LCM of B and C is 2000, and the LCM of C and A is also 2000, is N. We have to find the sum of the digits of N. Find the sum of the digits of N. So basically we have to find this number N. And N is the number of triples or triplets of integers such that A, B, and C, where three LCMs are given. LCM of AB, LCM of BC, and LCM of CA. So if the LCMs of these three pairs of numbers are given, can we find the number of possible such triplets, right? So in order to approach this problem, think about the LCM values. 1000 can be written as 2 to the power 3 times 5 to the power 3 in terms of its prime factorization, and 2000 is 2 to the power 4 times 5 to the power 3, right? So now if I have A is some number which has prime factorization 2 power x1 and 5 power y1, and B has prime factorization 2 power x2 times 5 power y2, C will have 2 power x3 times 5 power y3, and this is the prime factorization of ABC, where x1, y1, x2, y2, x3, y3 are unknown right now, right? We have to figure out how can we ensure that the LCM is these numbers, right? Notice that there cannot be any other prime factor in A, B, and C other than 2 and 5 because there are no other prime factors in the LCM. The only prime factors are 2 and 5. So those are the only prime factors that will be present in A and B and C as well, right? So now when you do LCM of A and B, you would be taking the LCM like this. You'll say 2 to the power max of x1 and x2 times 5 to the power max of y1 and y2. And basically that is known to be 1000. So what we know is that maximum of x1 and x2 is 3, and we know maximum of y1 and y2 should be 3 because it is 2 power 3 and 5 power 3 here. So if you analyze the exponents of these and look at the LCMs, what you end up getting is these results. You will get maximum of x1 and x2 is 3. The maximum of x2 and x3 is 4. And the maximum of x3 and x1 is 4. Why are we getting these results on the maximum of these numbers? Because when we take LCM, we take the higher power as the LCM. Whatever is the prime factorization of two numbers, we choose the higher power. So whichever is greater out of x1 and x2 will come as the LCM power of the exponent of 2 in the LCM of A and B, right? And similarly, we have three equations for y1 also. y1, y2 max is equal to 3. Max of y2, y3 is equal to 3, and max of y3, y1 is also equal to 3, right? So now we have to think about how many such triples are possible, right? So these x powers are powers of 2, and these stand for powers of 5, right? Powers of 5. So let's think about A, B, and C And what can be the powers of 2 possible for A, B, and C? So x1 and x2 maximum is 3. So we know for now that x1 is less than equal to 3 and x2 is less than equal to 3. From here, we know x2 is less than equal to 4 and x3 is less than equal to 4. And from here, we know x3 is less than equal to 4, right? So these are the conditions. x1 is anyway less than equal to 4. These are the conditions that we are getting for x1, x2, x3, right? So basically, you could have a situation where x3 is 4 and if x3 is 4, then right. So is it possible for x3 to also be 3? You should realize that x3 cannot be 3 because if x3 is 3, then max of x3 and x1 will be 3. Then this condition will fail, right? So x3 cannot be anything less than 3. x3 must be 4, right? Similarly, if x3 is 4, now we will take all the possible powers of A and B, x1 and x2, right? So we already know the power of 2 in C. So x3 is 4 is already known. So you could have x1 and x2 are both 3 and 3. So you will get basically 3, 3, 4 in that case. Then you could have x1 is 3, but x2 could be 0, 1, or 2 also, right? So there are 3 options here: 3, 0, 4, 3, 1, 4, 3, 2, 4. And then you could also do the case where x2 is 3 and x1 could be 0, 1, and 2, right? In that case, we will have pairs like triplets like 0, 3, 4, 1, 3, 4, and 2, 3, 4. Notice that in all of these cases, you will always satisfy these conditions. So I am just looking at these inequalities and I'm trying to list out the possible values of x1, x2, x3. x3 must be 4 always, and you're getting 7 other triplets here. So 7 ways. So we are getting 7 ways to assign the powers of 2, right? And then we have to think about the ways in which we can choose the powers of 5, right? And here you have all the 3 numbers could be less than or equal to 3. Everyone is maximum value is 3, right? So if you think about that, you will get y1 is less than 3, y2 is less than 3, and y3 is less than equal to 3, right? And the possible ways you could do that is, first of all y1 is equal to y2 is equal to y3 is equal to 3. That is also possible. That is one way. Then you can have, there are 2 3s and 1 2, right? So this 1 2 could be anywhere. So it could be 3 3 2 or 3 2 3 or 2 3 3. These triplets are possible because in each case you will say that the pair of 2 of them, the maximum value is always 3. Then there could be 1 3, there could be 2 3s and 1 1 also. This is also possible. 3 1 3, 1 3 3, and 3 3 1. These are possible because still the maximum value of any 2 of them is 3, right? And then the final case that is possible is 3 3 0. And again, 3 pairs will be there: 0 3 3, 3 0 3, and 3 3 0. There is no case where there is only a single 3 and there are 2 other numbers. There have to be 2 3s and or there could be 3 3s. So in all total, you are getting 3 cases here, 3 cases here, 3 cases here, and 1 case here, which is 3 3 3. So total, there are 10 ways to choose the powers of 5. Choose the powers of 5. So basically, whenever you construct these triplets of A, B, and C, whenever you construct the triplets, all you have to do is figure out what are the powers of 2 and 5 in each of the numbers. In each of the numbers, we have just now understood that there are 7 ways to choose powers of 2, and there are 10 ways to choose powers of 5. And accordingly, by multiplication principle, the total number of ways to make these numbers would be 7 times 10. So there are 70 possible triplets. For each possible powers of 2 combination, there are 10 different powers of 5 combinations. And there are 7 such pairs, possible powers of 2. So it is simple multiplication principle, and the number n, number of triplets, is 70. Therefore, the sum of the digits of n is 7. Sum of digits of n is 7. So understand how we did the problem. We first understood that we have to look at the prime factorization of each of those LCMs. We found out from there that the only prime factors of all 3 numbers are 2 and 5. And then we wrote inequalities on the exponents of 2 and 5 in all 3 numbers A, B, and C. After that, we focused our attention on powers of 2 and figured out that there are 7 ways to assign the powers of 2 for x1, x2, x3. And similarly, there are 10 ways to assign powers of 5 for y1, y2, y3. And that gives us the way to count the overall number. So I hope you have understood this problem. It's a nice question based on very basic concepts of number theory and LCM, and could be asked as a permutation and combination problem in JEE. So hopefully you learned how we figured this out. That's all for this video. I'll see you next time.